This is Math 139, Section 3.1, Part A. In Unit 3, we're going to be looking at exponential and logarithmic expressions. We'll start with the exponential ones. And in Part A here, we're going to look at the basic laws of exponents. First of all, what if you want to multiply two exponential expressions like a to the fourth times a squared? Well, a to the fourth really means a times itself, 4 factors. And of course, a squared is a times a. So I now have 6 factors of a in all, or a to the 6th power. You'll notice that what we ended up doing was just adding the exponents. So to multiply, add exponents. If I wanted to write that in a more general mathematical rule form, I could write a to the n multiplied by a to the m equals a to the n plus m. Notice that the base a had to be the same, and it stays the same in the final answer. I'm really just counting up how many factors of a I have. All right, what about division? Well, a to the 5th. In the numerator, I'm going to write out 5 factors of a divided by a squared. And we know that a divided by a is 1. And again, a divided by a is 1. So I'm now left with 3 factors of a, or a cubed. You'll notice here what happened is I really ended up subtracting the exponents. So to divide, subtract exponents. If I wanted to write that out as a mathematical rule, I could write a to the n divided by a to the m equals a to the n minus m. All right, next one. I have a to the 4th in parentheses, and I'm raising that to the 3rd power. So it's like taking a power raised to another power. If I think about what this means, it means a to the 4th times itself, a total of 3 factors. If I now use this rule that says to multiply, add exponents, I would just add 4 plus 4 plus 4, and get a to the 12th. Well, looking back, what really happened is I ended up multiplying those exponents, 4 times 3 to get the 12th. So if I'm taking a power to a power is how I'm going to abbreviate that. We'd like to multiply exponents. Again, writing that in a more formal mathematical sense, I could say a to the n raised to the m power is equal to a to the n times m. Multiply exponents. All right, in these last 2 lines, we have things in parentheses being raised to a power. If I have a product raised to a power, ab to the 4th power, that really means ab times itself, a total of 4 factors. But I now have 1, 2, 3, 4 factors of a, so that's a to the 4th, and similarly 1, 2, 3, 4 factors of b, so that's b to the 4th. And I really ended up applying that exponent of 4 to both factors inside my parentheses. So I can apply an exponent to, in this case, both, but in general I'll say all factors. I'm going to emphasize that word factors. That's really important. These can't be add-ins. They can't be subtracted. They must be factors in order for us to use this. if I do have some product in general, ab to the n power, that would be a to the n times b to the n. This works for division as well. If I have a fraction like a divided by b raised to the third power, that really means a divided by b times itself 3 times. And to multiply fractions, I multiply across the top. A times a would be a cubed. And multiply across the bottom, giving me b cubed. So once again, I can apply the exponent to both the numerator and the denominator of a fraction. In general, a divided by b to the n power can be simplified as a to the n power divided by b to the n power. All right, so there's our 5 exponent rules, or what we sometimes call the laws of exponents. In just a moment, we will take a look at some examples of using those. But before we do that, I want to emphasize again these last 2 rules with the parentheses. It was extremely important that I either had a product, in other words, factors, to apply my exponent to, or I had a quotient, a numerator and denominator, to apply my exponent to. Our rules here really only apply to multiplication and division. In fact, when you go back up, multiplication up here, right? And division here. And a power to a power is really just repeated multiplication. Down here, factors and division, a numerator and a denominator. Very, very important to keep in mind. All the rules that we're looking at apply to multiplication and division only. We actually studied the rules to take binomials or trinomials, things involving addition and subtraction, to a power back in the last unit. Remember, when we do that, we actually have to multiply it out using techniques like FOIL and distributive laws and things like that. So don't confuse that with these new rules that apply only to factors and then quotients, numerators and denominators. All right, let's take a look at a few examples. We're going to simplify each expression. Again, make sure that we think about whether we're using our polynomial arithmetic or our laws of exponents. If I have 3x squared, that's a product, it's multiplication. So I can apply the second power to both factors. 3 squared times x squared, giving me 9x squared. Now notice the difference over here. 3 plus x squared, those aren't factors. That's not multiplication. So instead, I need to multiply this out using my polynomial arithmetic techniques. That's really 3 plus x times 3 plus x. The firsts would multiply to 9. Inners would be a plus 3x, and outers would also be a plus 3x. So I get a plus 6x, and then plus x squared. Notice that if you tried to simply apply the exponent to the 2 addends, you would miss that middle term. So really important, if it's not multiplication or division inside your parentheses, make sure you write it out and multiply it out using the techniques that we've already studied. All right, number 3, x to the 5th plus x to the 5th. Again, this is adding, not multiplication or division, so I'm looking at polynomial rules. Like terms, I really just add the coefficients. So I would think of this as 1x to the 5th plus 1x to the 5th, giving me 2x to the 5th. The x to the 5th does not change when I add or subtract. When I multiply x to the 5th times x to the 5th, Now I'm using my new laws of exponents to multiply, add exponents. So I'll get x to the 10th here. So that first set of examples was just to sort of emphasize the fact that sometimes things can look just a little bit different, but the techniques are very different. So watch out for those common pitfalls. All right, we'll now move on to some slightly more complex expressions that we can simplify using our laws of exponents. Number 1, 4 cubed times 4 to the 5th. We're multiplying, so we add exponents. 4 to the 8th power. Notice the 4 didn't change, right? Just like up here. When I did x to the 5th times x to the 5th, the x didn't change. The base does not change. Only the exponents get added. All right, in number 2, I've got 2x to the 4th cubed. And I'm going to start by getting rid of those parentheses. I'm going to apply this exponent of 3 to both factors inside my parentheses. For right now, 3x to the 6th won't change. But then I'm going to multiply that by 2 cubed. And then x, power to a power, I multiply exponents, x to the 12th. That would be 3x to the 6th times 8x to the 12th. 2 cubed, just 8. And then 3 times 8 is 24. X to the 6th times x to the 12th. Multiplying, I add exponents. So x to the 18th. In number 3, I have a whole bunch of stuff inside those parentheses that eventually is going to get squared. But I'm going to notice that I could simplify inside the parentheses first, just like the old order of operations, right? Do what's in parentheses first. So let's do that. All right, 6/8 is just a regular old numeric fraction. I'll reduce that to lowest terms, 3/4. Dividing, I subtract exponents. So for the a's, 5 minus 2 would be a to the 3rd. B cubed is still going to be there. And on the bottom, c to the 5th will also still be there. Now I can go ahead and apply this exponent of 2. Because everything inside my parentheses is either multiplied or divided, I can apply that 2 separately to every single factor. Notice I'm going to use it 5 times. 1, 2, 3, 4, 5. So what do we get? 3 squared. A to the 3 times 2 would be 6. B also 3 times 2 would be 6. And on the bottom, 4 squared. C to the 5 times 2 is 10. We're almost done. We just want to go ahead and simplify the numerical parts. 3 squared would be 9. And 4 squared is 16. All right, one more example of these. Looking at number 4, I don't see inside the parentheses that there's anything that could be done. So I'm going to start right out by saying, let's remove the parentheses. This 3 can be applied to both factors. So I'll get x to the 9th, y to the 3rd, times x to the 4th, y to the 5th. I don't have to change anything there. There was no exponent outside those parentheses. Over xy squared. Let's finish the numerator. Multiplying x to the 9th times x to the 4th. I add the powers, x to the 13th. And then for the y's, again adding the powers, y to the 8th. Finally, keeping in mind that this is really an x to the first on the bottom, to divide I subtract my exponents. So 13 minus 1 would give me x to the 12th, and 8 minus 2 makes that y to the 6th. All right, that's the end of part A.